Hi guys, welcome back to my YouTube channel, Let's Crack Real Math. My name is Viraaj, and in this video we'll be having a look at the equation of the perpendicular to a straight line graph. So before I begin the video, please do not forget to perform an LSS, that is like, share and subscribe. And without wasting much time, let us begin. So what exactly is the perpendicular to a straight line graph? We know that if we have a straight line graph, this would look something like this. Let's say something like this. Let's just improve the thickness. Okay. So let's say I have something like this over here. That's my straight line graph. And what exactly is the perpendicular to it is simply another line that meets at this midpoint, so at the center of this line, at 90 degrees. So maybe something like this. But the most important term is that it creates a 90 degrees. That's what makes something perpendicular. And as we know, since one makes 90 degrees, all four of them would make 90 degrees. And if you add up all four of them, that would give you 360 degrees, and that is the amount of degrees you have in a full circle. So that's basically how a perpendicular looks like. Now we know from knowledge, and if you are not comfortable with this, you should look at my video on equation of a straight line graph. We know that it's an equation of a straight line graph is something like y equal to mx plus c, where m is the gradient. So obviously the perpendicular line would also have its own y equal to mx plus c, but now how do you manipulate it to find the equation? All you have to do is, because they would, like in questions, they would give you some coordinates, so you can always plug in those coordinates of x and y to find your c. To find your m, all you have to do is take the reciprocal of the straight line graph and change the sign. Now, it may sound complicated at first, but let's break it down. What is reciprocal? If I have something like 3 over 4, the reciprocal is nothing but the numerator to the denominator now, and the denominator to the numerator around. So just flip it around. This would become 4 over 3. The reciprocal of 3 over 4 is 4 over 3. If I have something like 7, only 7, what's the reciprocal? It's 1 over 7. Why 1 over 7? Because we know that this 7 is over 1, and we put the denominator as our new numerator, which becomes 1, and our numerator, which was 7, becomes the new denominator over here, which is also 7. If I have something like 10 over 9, the reciprocal is now 9 over 10. So you just flip it around. Now, I said that you should always take the reciprocal and change the sign. What I mean by change the sign is take the opposite sign. If I have, say, minus 3 over 9, okay, let's do minus 3 over 10. If this is the gradient of the straight line graph, the gradient of the perpendicular to the straight line graph would be the reciprocal and the opposite sign. So the reciprocal of 3 over 10 we know is 10 over 3, and opposite sign means that the sign that's over here is the opposite sign that's going to be over here, so it's going to be plus 10 over 3. But in mathematics you don't need to add the plus, because we know that when there's no sign in front, it's considered positive. If I had, say, something like 5, then if this was the gradient of a straight line graph, then the gradient of the perpendicular to the straight line graph would be the reciprocal, which is 1 over 5. Remember, 5 is the same as 5 over 1, and it would be minus 1 over 5, because we know that since there's nothing over here, this is simply plus, and the opposite sign to plus is minus. So change of sign and reciprocal, that's the two important things. So now that we have a bit of a ground foundation on this, let's dive into examples. Right, first example I have says, find the gradient of a line which is perpendicular to the line joining A 7, minus 2 and B 5, 4. Okay, let's read it again. Find the gradient of a line which is perpendicular to the line joining A and B. So suppose I have A over here and I have B over here, and there's a line that goes from here to here, and I need to find the line the gradient of the line that's perpendicular to this. Now, in lots of questions, you would also have to find the midpoint. However, in this question, there is no need, because we're not finding the exact equation. We're just trying to find the gradient of the line which is perpendicular to A and B. So we know to find the gradient of A and B, we do y2 minus y1 over x2 minus x1. Doing this, we know our y2 is 4 and our y1 is minus 2, so 4 minus 2 and then our x2 is 5, and our x1 is 7. Doing this, we know 4 minus minus 2 is 6, because 2 minuses become a positive. Remember, minus is the most dangerous sign in math. And then 5 minus 7, that's 6 minus 2. So 6 over minus 2, this is nothing but minus 3. So this is the gradient of this line. Okay, not that line. Let's say this is the gradient of this line right here, A to B. This is the gradient of that line. Now the question said find the gradient of the line which is perpendicular to the line joining A and B. So if I have minus 3, all I have to do is find the gradient of perpendicular to this, and as I said, we take the reciprocal and change the sign. We know this is minus 3 over 1. So taking the reciprocal, you would have 1 over 3. And since there's a minus over here is going to be a plus. However, we won't write the plus because it's more professional not to, as we know that if there is no sign, it's positive. So simply, the gradient of the perpendicular is 1 over 3. Let me just explain it again. I have minus 3 here. We have to take the reciprocal and change the sign. So if I know there's a minus here, I know that the gradient of the perpendicular would be positive. So automatically I know that's positive. That should usually gain you 1 mark. And since we have 3 over here, or minus 3 in this case, we know that any whole number, let it be 9, 99, or 1000, it's all basically over 1. And all you have to do is just switch around the numerator and denominator. So this now becomes a numerator and this becomes a denominator, as it happened over here, 1 over 3. So on to the next example. Right, this one says find the gradient of a line which is perpendicular to the line joining 0, minus 2 and A 0, minus 2 and B 3, 5. So again, we need to do the first things first. We need to find the gradient of A and B. Again, we have something like this. This is a line deep, and we need to find something like the perpendicular to this, the gradient of the line that's perpendicular to this. Again, I'm just illustrating as if it's horizontal and vertical lines. It could be something like this and this, or it could even be something like this and this, just, yeah. So, using our y2 minus y1, we know it's going to be 5 minus 2, because our y2 is 5, our y1 is minus 2, okay, sorry, it's not 5 minus 2, it's 5 minus minus 2. Remember, minus 2 is separator, and we know we're subtracting, and then we do x2 minus x1, that's 3 minus 0. 5 minus minus 2 gives you 7 all over 3, because 3 minus 0 is 3, and 5 plus 2 becomes 7, since 2 minuses give a plus. And this is the gradient of the line, and now we need to find the gradient of the line which is perpendicular. So we have 7 over 3, all we have to do is take the reciprocal and change the sign. Reciprocal of 7 over 3 is you simply change around the numerator and denominator, so this 3 becomes the numerator now, and the 7 becomes the denominator. It's from 7, and again, the change of sign. Over here it's positive, we know that because there is no sign there in front, and if there is no sign it's positive. So this would become minus, and the gradient of the perpendicular to that line is nothing but minus 3 over 7. On to the next example. Right, this one says find the equation of the line that passes through the point 5, 0 and is perpendicular to the line y equals mx plus c. Okay, so sorry guys, that was a wrong question, wrongly copy and pasted by me, so apologies. This is the redeemed question. Okay, it says find the equation of the line that passes through the point 6, 2, okay, good to know, and is perpendicular to the line y equals 2x plus 4. So first things first, this time we're trying to find the equation rather than the gradient. So the equation we will find is in the format of y equals to mx plus c. Now they gave us a coordinate, they gave us 6, 2, and it says, and it's perpendicular to the line y equals 2x plus 4. So this is the line y equals 2x plus 4. Let's just represent it with something like this. And to find the line that's perpendicular to this, let's say something like this. So this line is y equals 2x plus 4. So from y equals to 2x plus 4, we know that 2 is simply our gradient. And now, in order to find the gradient of the perpendicular, we know is that we take the reciprocal and change the sign. The reciprocal of this is nothing but 1 over 2, and if you change the sign, the positive over here will simply become the minus over here. So we have the gradient of the perpendicular already, which is minus 1 over 2. Now, if I were to write this in the form of y equals mx plus c, I know that m is my gradient, that's y equals to minus 1 over 2 x plus c. So now the question arises, how do I find my c? If you notice, they gave us a coordinate. They gave us 6, 2. We know from this that 6 is our x and 2 is our y. So all we have to do is substitute these values into this equation over here. So we now have 2 equals to minus 1 over 2 into 6 plus c. So the 2 went here into y and the 6 went all the way here into x. Doing the necessary, we know this is 2 equals to minus 3 plus c, because 6 times minus 1 over 2 is minus 3, and c is nothing but 5, because minus 3 goes to the other side and becomes positive. So c equals to 5, and since c is your 5, you can now rewrite the original question in the equation. So you can now write it as y equals to minus half x plus 5. Always do remember to write it back in the format of y equals to mx plus 5, because sometimes a lot of students just get the c and leave it as it is. They expect the examiner or the marker to know that how they need to know how to write the answer, but you need to always show how exactly you derived your answer. And on to the final example for this video. Right, this one says find the equation, again equation, not gradient, equation of the perpendicular bisector of the line joining 3, 2 and 7, 10. So again, first things first, as I went to the format of this question, in this case we do not exactly have the equation of the line, but however we can always find the equation of the line. So first things first, let's find the gradient. We know gradient is y2 minus y1 over x2 minus x1, so 10 minus 2 all over 7 minus 3. Doing this, I have 8 over 4, and then I have 2. So I know that the gradient is, okay, let's just write the gradient. We know that the gradient is 2. Now that we have the gradient of this line, we know that the gradient of the perpendicular bisector would be the reciprocal of 2, the reciprocal and the opposite sign. So we know it's 2 over 1, reciprocal would be 1 over 2, and change of sign would make it minus, so minus 1 over 2. So that is the gradient of the reciprocal. Now, because we do not have an equation or the equation of the line P to Q, we need to find the midpoint. As I said earlier in this video, when you're not specified to when you're told to specifically find the equation of a line and you're not given the other equation, which in this case is y equals 2x plus 4, in this case we do not know, we need to find the midpoint. So we know that midpoint is simply x1 plus x2 over 2 plus y1 y1 plus y2 over 2. So 3 plus 7 over 2, 2 plus 10 over 2. This would be 5, 6. Because 3 plus 7 is 10, divided by 2 is 5, and 2 plus 10 is 12, divided by 2 is 6. So we have the midpoint. Now, since it told us to find the equation of the perpendicular bisector, we know that since the gradient is now minus 1 over 2 of the perpendicular, we know that we have something like y equals to minus half x plus c. Now, why exactly did we find the midpoint? We know that if we have something like this, let's say this is the original straight line, PQ, and we're trying to find the perpendicular line to it. Let's say it goes something like here. The perpendicular bisector goes through the midpoint of P and Q, and that's what we found. If this is, if P is 3 over 2, 3, 2, just an assumption over here, and Q is 7, 10, Then the midpoint of P and Q, which is somewhere here, is simply 5,6. And as you can see, the perpendicular, which is this line from here to here, goes through 5,6, sorry. So all you have to do is just put this 5 in place of x over here, and this 6 in y over here. So doing that, we have 6 equals to minus 1 over 2 into 5 plus c. This is 6 equals to, let's just quickly do minus 1 over 2 times 5. It should be minus 2.5, but let's just confirm. Yep, it is minus 2.5 equals to minus 2.5 plus c. And taking the minus 2.5 to the other side becomes positive, so it becomes c equals to 6 plus 2.5, which is 8.5. So now we can write this as our final equation of perpendicular bisector, which is simply y equals to minus half x plus 8.5. You can leave your answer like this, or you can simplify it even more by timesing everything by 2 in order to get rid of the fraction. And doing that, you would have 2y equals to minus x plus 17. Both answers are valid and are correct and should get you your marks. So that example brings us to the end of this video. So hopefully you enjoyed it, guys. Please do not forget to perform an LSS, that is like, share and subscribe, and thank you for watching. Have a nice one, guys.